Unit 9, Topic 5, Vertex on the circle. Tangent lines are lines that hit the circle at exactly one point. Tangent lines will never go inside the circle. Looking at some examples of tangent lines, we see that they always graze just the outside of the circle. Some examples of lines that are not tangent will go inside of the circle. Secant lines are lines that hit the circle at 2 points. Here are some examples of secant lines. Notice how they hit the circle at 2 points. They do go through the inside. Some examples of not secant lines just graze the outside. Tangent lines are not secant lines. Chords are secant line segments with endpoints on the circle. One example of a chord is right here. Notice how its endpoints are on the circle. When two tangent lines intersect, two chords intersect, two secants intersect, or any two types of lines intersect, an angle is formed. To solve, the key is to find where the vertex of the angle is located. Today, we're mostly going to look for when the vertex is on the circle. That is, two lines cross on the circle. When two lines cross on the circle, we're going to find that if we take 2 times the angle measure, it's going to equal the arc measure. Now, noticing the picture on the left, we see that the angle is across from an arc that has the diameter as endpoints. Because half of a circle is 180 degrees, and 2 times the angle equals the arc, 2 times the angle is going to equal 180 degrees. So dividing both sides by 2, we find that when the arc has the diameter as endpoints, the angle across from it will be 90 degrees. When angles have the same arc, the angles will be the same. So we notice that we have an arc here and 4 different lines coming off of it. So both the angles formed will have the same measure. Now let's find the measure of an angle 1. When the vertex of an angle is on the circle, as it is here, we'll find that 2 times the angle will equal the arc. So 2 times angle 1 will be 54 degrees. Divide both sides by 2, and the measure of angle 1 is 27 degrees. Now, let's find the measure of angle 2. Well, when the vertex of an angle is on the circle, 2 times the angle will equal the arc. So 2 times angle 2 will be 126 degrees. Solving for angle 2, we'll divide both sides by 2, and we find that angle 2 is 63 degrees. Now, let's find the measure of angle 3. So, to solve for angle 3, we're going to need the arc across from it. Using what we know about circles, we know that all arcs in a circle will add to 360 degrees. So if we take the arc that we need, plus the 110 degrees, plus the 90 degrees that we're given, they will all add to 360 degrees. Combining like terms, that means that the arc we need, plus 200 degrees, will equal 360 degrees. To solve, we'll subtract 200 from both sides, and we find that the arc we need is 160 degrees. Now, when the vertex of an angle is on the circle, the 2 times the angle will be the arc. So if we take 2 times angle 3, it's going to equal the 160 degrees we solved for. Dividing both sides by 2, we find that the measure of angle 3 is 80 degrees. Now let's find the measure of angle 4. So the arc we need is going to be the rest of the circle. Because all arcs in a circle add to 360, if we take the arc we need plus 150 degrees, it'll equal 360 degrees. So subtract 150 from both sides, and we find that the arc that we need is 210 degrees. Now, when the vertex of an angle is on the circle, we know that 2 times the angle equals the arc. So 2 times angle 4 is 210 degrees. Divide both sides by 2, and angle 4 is 105 degrees. Alrighty, find the measure of an angle A to C to D. Alright, the arc we need when the vertex of an angle is on the circle. 2 times the angle equals the arc. So, because angle 86 degrees is across from the arc we need, 2 times 86 degrees will equal my arc. 2 times 86 degrees is 172 degrees. So the arc we need is 172 degrees. When the vertex of an angle is on the circle, 2 times the angle equals the arc. So 2 times the angle ACD is going to be 172 degrees. To solve, we divide both sides by 2, and we find that angle ACD is 86 degrees. Inscribed angles with the same arc will have the same value as we heard before. Now, let's find the measure of an angle A to D to C. So, the arc across from A to D to C is what we need. And we know that semicircles are 180 degrees. So when the vertex of an angle is on the circle, 2 times the angle equals the arc. So 2 times angle ADC is going to be 180 degrees. Divide both sides by 2, and angle A to D to C is 90 degrees. Diameters create inscribed angles measuring 90 degrees, always.